yours. Thank you very much. Good morning, everyone. IIP-Ecosphere, an open ecosystem for production. What is this about? What do we understand by the word ecosystem? I'm going to speak to you about the topic AI, and then my colleague Mr. Eichelberger is going to take over and speak about the IoT platform. First of all, why do we need an ecosystem for the intelligent production? We conducted a survey. We asked 75 companies in cooperation with the VDW. About 60% of them see added value for their products and services, which is not that surprising. And more than half, approximately 55% of the companies surveyed, they expected a change in their business models. So they say there are new ways of earning money. But only about 8% of the companies surveyed are already employing AI. So there's a bit of a gap, really. The vision and the aim of IIP-Ecosphere was to say, well, we're going to take a holistic approach to the topic and do something with the objective of companies being enabled to employ AI in their production. So we approached these partners in an interdisciplinary approach. So we have companies such as DMG, Mori, Gerresheimer, Sennheiser, Volkswagen, companies in production. We have research partners in production, computer science and business information. We have associations and multipliers such as VDW, AI companies, as well as system providers such as Lenz and Sennheiser. I will talk to you about a use case which is going to serve as an example in production where we see potential for the use of AI. I will also talk to you about why we need an ecosystem and how we interpreted this topic and how we actually implemented it from a technical point of view, which is what Mr. Eichelberger is going to speak about. Our institute's focus is, which is why I'm giving you this example, this milling process. So you can see this process. On the left, you can see the tools. On the right, we have the workpiece. On the video, it looks fairly simple, but it is a fairly complex process, actually. When you adjust the parameters, I can only do so with a certain amount of expert knowledge. If I adjust it incorrectly, then the quality is going to be poor. That is why we employed a reinforcement learning agent that would set parameters for the process. And we have a process simulation that will predict quality parameters. And based on this, this reinforcement learning agent will then suggest new process parameters. That much worked. We were able to improve the quality. So one might say, well, we're done. We're done here. You know, the result is satisfactory. And at that point, from production technology, that is where we leave things off. However, I would like to remind you of this 8% of companies that employ AI, which is due to something. And that is connected to the fact that this AI solution essentially is just the tip of the iceberg. So the question is, how do I get the AI to the machine? Machines from different manufacturers. It has to be interoperable. What do I do if I have to update these AI models? If the machine changes, so I have to update the reinforcement learning agent. Also, you will notice that if this is to work well, then you need data from many users. Actually, you can't just have a few users. So I need to implement data sharing. Of course, I need to clear up any legal issues connected to data protection and personal references, and many more points. And, well, so you do need a certain type of platform, and my colleague, Mr. Eichelberger, is going to have a look at the details. And this is where research projects usually think about what might be needed. They will set up a beautiful architecture and nothing gets produced. So at various points, the response would be that you approach one of the larger manufacturers and you simply purchase it, but the times are changing. Things are changing, and so we said, these things which were outlined by my colleague Mr. Schreiber, we will implement in software, and we're going to try it out. So in current production, you can have a look around in hall number 9. You will see many marvelous machines. Some companies have already linked them up. They bring them together. Other companies are still at the very beginning of their process. They still use pen drives. But on the other hand, they would like to get to a point which Mr. Schreiber just explained. They would like an AI to come in to help them to predict parameters for a machine and to carry out these processes. So now you have to merge these two worlds. You have the real-time world and you have the IT on the other hand. Over the past years, many things have happened, such as edge devices, which you can simply screw to those devices. So you can enable older machines which have been running for 20 years, and you can integrate them fairly well in your operations. And there are more machines, more edge devices that are growing. You can see one at our booth, which is fairly large, which usually doesn't get implemented, and which actually has the capability for AI in real time. Many manufacturers and many users also think that when they have such a machine, they need to enter the cloud immediately. And this is quite frequent, the one thing that the users want, but what Peter mentioned, at least 50% of the German SMEs, they say, well, a cloud architecture is not quite necessary. So it's about the transfer bandwidths that might be limited, but also the typical argument of people saying, well, in production, they want to retain their own data because otherwise the competitors will be able to infer too much information from that data. We have a heterogeneous type of protocol landscape. So even if you approach the Omati colleagues, they say, of course, they speak OPC UA, but it has a different look. It's not standardized. And with a heterogeneous world, you have to manage somehow. So the standard approach is, of course, buying a massive tanker, a huge Industry 4.0 platform, which is a massive part of software that includes many functions, but as a user, you might not be able to intervene as to how you would like to integrate your data in that production process. So what we said is, why do you need a tanker? Why don't you just use a speedboat or a yacht? Why don't you just pick the boat that you would like? Could be a sailboat too. As I said, whether this be a yacht, a sailboat, it doesn't matter. It should be up to you. The decision should be yours. Also, whether you want to make use of the cloud or whether you don't. So this was the starting point where we said, let's have a look at what the platforms are not capable of. We investigated 21 industrial platforms, and we wondered whether we could do what we envisioned in the project. Can this be implemented in reality? So we approached them. We carried out the industrial survey in cooperation with the VDW, and there are some points where users are not happy about what the larger platforms do, especially when you have a look at the initial costs. And then we started looking for requirements with our industrial partners, and we had a look at it from two types of perspectives. So we produced 2 reports, including more requirements than we actually implemented, because we wanted to have a look towards the future for different types of users, for different types of projects as well. So you might say, well, they determined requirements, maybe they assembled an architecture. Is there such a platform that was developed by us? And in fact, we actually put this in practice in 3/4 of a year. It actually exists. It's open source. You can use it. You can try it out. And that is why I didn't want to speak about the architecture, and the actual underlying structure, but I wanted to talk about what we think about the special properties, the special traits of the work that was carried out. One thing that arose from the survey, if I buy such a huge tanker, what's the initial cost? Is it going to be worth it? You know, it's usually a 6-digit number, and management say, well, let's not purchase it. However, there's a growing number of companies that say, well, open source is the right approach, even if we need to gather the competence, gather the knowledge. But once we have done so, we can actually have a look at the software, and we can add those modules which we might not be able to obtain from a larger manufacturer because it's not part of the roadmap. So at that point, you have a connector between openness and cost reduction. And we see many companies going in that direction. Something that we do offer, and it sounds like a standard platform, would be multiple connectors for the integration of your machines in order to tame this heterogeneous world of programming languages. And we take it one step further. You don't have to program those connectors yourself, but we generate them for you. You describe the type of data which you would like to process, what kind of data you would like to process from the outside, from your machines, which you would like to integrate in your machines, and we create the rest for you in an automated manner without you having to look into the details. They always look the same, they work, and we save you a large amount of work. And that is why, in order to be able to create these connectors, we also use, and that is what the industry tried, what they tried to push us towards, to use standards, the big ones, OPC UA, MQTT, and the new Industry 4.0 standard, which was trending a bit more, would be the AAS standard, which you can integrate in an automated manner. You can also customize it, and you can even program it yourself if you want to. Another story, and this is me getting back to the topic of the cloud in the beginning, and that is the fact that some companies do not want to share the data, and they may have good reason not to. And that is why we implemented this as one of our principles, that the data is processed exactly at the point where you want them to be. If you want to use the cloud, you receive a cloud connector. If you do not, then we cut out the cloud connector from the platform. So we can guarantee to you that the data will remain in your company unless you integrate an application doing the opposite. I said it in the beginning, edge devices are clearly the trend. They are close to the machines, so you can keep the latency down for processing in the cloud. So it can be processed in real time or near real time. You can react to any sort of issue that comes up. And that is the reason why we investigated this, why we researched it, and why we implemented the solution in the end. So those parts in your application responsible for artificial intelligence, which you want to use as a service with the mechanisms of the platform, we can break it down to the edge level. So at that point, we're simply describing what components your application consists of, and then we describe where the individual components go. And you leave the rest to the platform, which at different positions in your system, it actually distributes them and makes them work. This works for fairly small machines as well, also machines from the manufacturer Phoenix Contact. So regular AIs that weren't written by industrial experts, we actually used one, and it worked with decent latencies, and that actually worked. So it can be done. And we took another step forward. We tried to take a burden off your shoulders by relieving you of the work, which is the work that usually leads to you making mistakes. That is routine applications such as the transfer of data, integrating data services in a data flow. And that is something that we do by having you describe your application at a high level to add the components which are specific to that application, such as the AI, and the rest is simply generated for you. If you come to our booth, the two applications that are running are actually generated up to 80%. So that is work that your developers won't have to engage in. They can take care of more important things. And for that, in the generation, we also include the corresponding tests, so that before you actually employ the application, you can try it out, so you have a high probability of them working out well for you. So for AI applications, and this is the bridge to what Mr. Schreiber said earlier, we need the option to actually get the AI somewhere, to integrate it, and that is why we're giving you the opportunity in this way, which I'm showing to you. Have a look at this graph. It's different from other applications. We have individual components which you can reuse. You assemble an application, you can link them up, and our platform actually looks at whether it makes sense, what you're doing, so it won't break during the runtime, and then we initiate it for you in the application, and the corresponding edge devices, they will simply run, and they can also be removed without anything happening. Nowadays, with modern edge devices, this happens through containers, and we also build those containers for you. So the model knows what you're going to require, what kind of software you will need, and based on that, you will also be given the correct containers which we deploy for you. So there's a whole array of things that actually make your work easier and eliminate the potential for mistakes or errors. And at the end of it, there's a flexible adaptation to your needs by the platform. So this is not a set, let's say, software package like the tanker, but rather you tell us which components you need, what kind of transport protocol, what the names of your machines should be. You tell the machine, you tell the program, and it sets up your own personalized platform, which is going to run on your personal devices. We believe those are 8 reasons, 8 ideas, which make our approach unique. Unique as compared to other approaches that we have seen in the industry. So you might say, does this actually work? I mean, this guy up on the stage, he can tell us a lot of stuff. He can make all sorts of promises. But we set up these 3 public demonstrators. None of them were easy to implement, since they reflected the very tough industrial reality on a small scale. So we used edge devices, cobots, industrial cameras, sensors. You can see light over here, controlled in real time by edge devices. This is something that we assembled, and we started with a visual AI-based quality inspection, which still is a part of our current demonstrator. We extended it with a federated learning procedure with the principle that you receive the data from the outside without you having to actually engage. And the current demonstrator at H22, that demonstrator is combining the magnetic product identification, condition monitoring, and a visual AI-based quality inspection, which I mentioned earlier. And for each of those demonstrators, the development approach is to save you work, to create components in an automated manner, and to deploy it to the edge level, and that is what we do. Something that we're very proud of is that those are not just our contributions, where maybe we sat down and the colleagues of IFW, but actually we have received contributions from 8 partners. So this is certainly a reflection of our ecosystem at this table of people who got together in order to make this work, to gather ideas, and to actually implement it, to make it a reality. At that particular table, you will also find the standard components, which you would find at other booths, but in a different type of combination, standard protocols, standard tools that will help you visualize the process. So I would just like to say you couldn't do it without a great team. So these 8 partners, they really had to work together, they had to contribute, and they did so in a great manner. It has been 9 months. Our time is almost up. So now we're wondering, where are we going? For the industry, it's always nice to see a research project somewhere, but of course you wonder, is there going to be a company if you have created such a great platform as I'm trying to describe to you? So what we're doing step by step at the moment is to walk down that path, and we're trying to carry out on-site evaluations on the shop floors. This is something that was promised to us. There is one name that I may mention, which is Phoenix Contact. They're going to support us in this. to process their data and see how AI interacts with that, with those data sets. We're always looking for new exciting use cases, and as of yesterday, we yesterday had our closing symposium. Now it's not called IIP-Ecosphere anymore. We actually changed the name. The new name is Octoflow, which is going to be the name of the company to be founded. This is going to take some time, of course, but if you would like to learn more about this, whether this might be interesting for you in the future, please have a look at our booth, just opposite Hall 9, booth H22. You can see it on the slide. Just over there where the two cobots are moving, that's where we are. That's all I had to say. Thank you very much for your attention, and bye-bye.